Hey everyone. It seems like AI is just everywhere these days, especially all this talk about large language models, LLMs,
Mm-hmm.
the ones that can write poems and code and stuff. Crazy. But you know what? Today we're taking things a step further. Our deep dive today is all about large concept models, LCMs. They're like the next evolution, I guess you could say. And we're diving into this really interesting research paper from Meta all about them.
It is a fascinating paper, really opens up a lot of possibilities.
Okay, so let's start with the basics. What are these LCMs? And how are they different from the LLMs we keep hearing about?
Well, think about it this way. Imagine a student cramming for a history exam. They might memorize all the dates and all the names.
Yeah.
But do they really understand the why behind the events? That's the big difference between LLMs and LCMs. LLMs are great at processing information, like the words and phrases. But LCMs are designed to grasp the actual concepts themselves.
Interesting. So it's less about just memorizing facts and more about understanding the bigger picture.
Yeah, exactly. LLMs are like those students who ace the multiple choice. But then they struggle with the essay questions. LCMs, on the other hand, they can connect the dots. They understand the relationships between ideas.
So that would make them much more adaptable and powerful.
Absolutely.
Yeah.
That's what makes this research so exciting.
I see. The Meta paper uses this analogy of an exam hall to show this difference. They say LLMs are like the students who just memorize the facts, and LCMs are like those students who actually understand the concepts behind them. I like that. So how does that play out in a real world situation?
Okay, let me give you an example.
Mm-hmm.
Imagine a tourist in a busy mall, and they really need to find a restroom. But they don't speak the language. All they can say is toilet, toilet, getting more and more frantic.
Okay, yeah. Poor guy. Couldn't they just do a search on their phone or something?
Well, yeah, they probably could. But that's where the nuance of these LCMs comes in. An LLM, just focusing on the individual words, might totally miss the context. It might just translate toilet, literally, and give them a list of plumbing supply stores.
Oh, right. It wouldn't understand the urgency.
Exactly. But a human, and hopefully an LCM, would pick up on all those nonverbal cues. The frantic behavior, the repeated word toilet. They'd understand the context and point the tourist in the right direction.
Wow. So it's they're thinking more like a human, taking in all those subtle cues to figure out what's really going on. So how do they actually do that? What's happening under the hood to make that possible?
It all comes down to how LCMs process information. Instead of focusing on individual words like LLMs do, they operate at the sentence level. They treat each sentence as a complete concept.
So they're not getting hung up on individual words. They're looking at the whole sentence as a unit of meaning.
Precisely. This allows them to understand the context and the nuances of language much better. And to do this, they use these things called sonar embeddings.
Okay, now we're getting technical. What are sonar embeddings?
You can think of them as a way to give each sentence a special code, a code that captures its meaning. It's not just about the words themselves. It's about the concept the sentence conveys.
So it's like giving each sentence its own fingerprint, its own unique ID based on meaning, not just words.
That's a great way to put it. And here's the really interesting part. Sonar embeddings aren't language specific.
So they can understand and generate text in multiple languages.
Exactly. This opens up a whole world of possibilities for cross-lingual communication and understanding.
Incredible. Having a universal translator that actually understands the meaning, not just the words. But hold on. Let's go back to those sonar embeddings for a sec. Can you paint a clearer picture of how they work?
Okay, sure. Imagine a huge library filled with books. Books in every language you can think of.
Okay, got it.
Now imagine you have this special tool. It can scan each book, not just for the words, but for the concepts and ideas behind them.
So it's like creating a map of knowledge, a web of all these interconnected concepts across different languages.
Exactly. That's essentially what sonar embeddings do. They allow LCMs to represent sentences as points in a multidimensional space, where similar concepts are clustered together, regardless of the language they're expressed in.
Okay. Starting to get it, but it's definitely a lot to take in.
It is. We're really just scratching the surface here. The main takeaway is that this shift from word-level processing to concept-level processing, it's a total game changer for AI. It allows for a much deeper, more nuanced understanding of language and its meaning.
This is all so fascinating. I feel like we're on the edge of something big here.
It really is an exciting time.
Yeah. But let's not get too carried away. We need to figure out how these LCMs stack up against LLMs, the ones we're already familiar with. What are the main differences?
Well, first of all, their core mechanisms are completely different. LCMs use those sonar embeddings we've been talking about, and LLMs rely on a different architecture called transformers.
Ah, transformers. That's what powers those text-generating LLMs we've been hearing so much about, right?
Exactly. But while transformers are great at predicting the next word in a sequence, they don't really grasp the deeper meaning behind those words.
So it's like the difference between knowing that something is true versus understanding why it's true.
Yeah, you got it. And that's just one of many interesting differences between these two models. The paper actually has a whole table comparing them across several different dimensions.
Okay, I'm intrigued. Let's dive into that comparison and really break down the strengths and weaknesses of each model.
All right, so that table is a great place to start to get a sense of what each model brings to the table. It compares things like how they process information, their reasoning capabilities, and even how they handle different languages.
Okay, cool. Walk me through it. What's the first big difference that stands out?
Well, we kind of already talked about it. The basic building blocks they use. LCMs work with concepts, which are essentially whole sentences, and LLMs focus on individual words or tokens.
Right. And that difference seems to have a big impact on everything else. It's like comparing apples and oranges. Or maybe like comparing a fancy chef with a master baker. Both are super skilled, but their expertise is in different areas.
I like that analogy.
Yeah.
And just like a chef might excel at creating these complex flavors, LCMs are made for tasks that need a deeper understanding of meaning and context, for example. They're much better at handling things like semantic reasoning, understanding the relationships between different ideas and concepts.
So they're not just spitting out words, they're actually getting the logic and the meaning.
Exactly. And that leads us to another difference, multilingual capability. Because LCMs use those sonar embeddings, they can understand and generate text in lots of different languages.
Oh, wow. So they don't need to be trained separately for each language, like a lot of LLMs.
That's right. They're inherently multilingual, which opens up so many possibilities for translation, cross-cultural communication, and all kinds of things.
It's like having a built-in universal translator that actually gets the nuances of all those languages.
It's pretty amazing.
Yeah.
And that ability to handle multiple languages so easily comes from the fact that they're working on this conceptual level, not just word by word.
Okay. I'm seeing a pattern here. LCMs seem a lot more flexible and adaptable, and LLMs seem more specialized.
Yeah, that's fair to say. And that adaptability also shows up in how they handle long-form content. Like, think about writing an essay or a report. You need a lot of coherence and structure.
Yeah, you got to keep those ideas flowing.
Yeah.
And make sure everything connects.
Exactly. And that's where LCMs shine. They process whole sentences as units of meaning. So they're super efficient at creating text that's coherent and structured, even for longer pieces.
That makes sense. They're not getting bogged down by every single word. They keep that big picture focus, even as the text gets longer.
Right. LLMs, though, can sometimes have trouble keeping that same level of coherence over long stretches. They might be great for short bursts of text, but for longer, more complex pieces, LCMs seem to have an edge.
So if I need to write a quick social media post, maybe an LLM is the way to go. But if I'm working on a big research paper or a report, I'd probably want an LCM.
That's a great way to think about it. Choose the right tool for the job. Understand the strengths and weaknesses of each model.
This is all so cool. But I gotta admit, I'm still a little fuzzy on some of the technical stuff. Like, the paper mentions quantization and diffusion when talking about LCMs. What do those even mean? And why should we care?
Those are some techniques researchers are using to make LCMs even more powerful and reliable. Think of them like fine-tuning adjustments, ways to optimize their performance, make them less prone to errors.
So it's like taking a high-performance car and making it even faster and more stable.
Yeah, exactly. The goal is to push the boundaries of what's possible, see how far we can take this technology.
That's exciting. But let's zoom out for a sec and bring it back to our listener. Why should they care about all this? Like, what's the takeaway for someone who's not a total AI expert?
That's a great question. I think the most compelling thing about LCMs is their potential to create AI that's more human-like in how it understands language and how it solves problems.
It's like we're moving from AI that just mimics language to AI that can actually understand and reason like we do.
Exactly. Think of the possibilities. More intuitive virtual assistants, seamless communication across cultures, even personalized learning experiences that adapt to your needs.
That's incredible. It feels like we're about to enter a whole new era of AI, where it becomes a much more powerful partner in our lives.
It's definitely a future worth getting excited about. And as research in both LCMs and LLMs keeps advancing, we'll probably see even more specialized versions emerge, tailored for very specific tasks and areas.
It's like we're opening a door to a whole new world. But with all this talk of AI that can think more like humans, it makes you wonder about the implications. Are there any downsides or risks we should be aware of?
That's a really important question, and one that researchers are actively looking into. Like any powerful technology, there's always a chance for misuse or unintended consequences, so we have to approach these developments responsibly and carefully consider the ethical implications.
So it's not just about what's technically possible, it's also about making sure this technology is used for good and not for harm.
Absolutely, and that's a key point. This deep dive isn't just about the technical details of LCMs, it's about understanding their potential impact on society, on how we understand ourselves.
It's like we're looking in a mirror, trying to figure out what it means to create something that can think like us. But are we really creating something that thinks like us? How do we even define thinking in the context of AI?
That is a huge question. Philosophers and scientists have been debating that for centuries, and it's becoming even more relevant now. As AI keeps evolving, we might not have all the answers. But one thing's for sure, the more we learn about AI, the more we learn about ourselves.
It's a journey of discovery, about the technology, and about our own place in the world.
Exactly. And it's a journey that needs curiosity, critical thinking, and a willingness to embrace the unknown.
I love that. It's not just about AI learning from us, it's about us learning from AI too. And speaking of learning, I think it's time to wrap up this deep dive into the world of LCMs.
I agree. It's been great exploring this with you and with our listeners.
But before we go, I want to leave our listeners with one last thought. We've been talking about all this amazing potential of LCMs, but it's still kind of early days, right? What are the big unknowns? What are researchers still working on?
Yeah, for sure. It's like we've just discovered this new continent, and we're just starting to map it all out.
So what are some of those uncharted areas?
Well, one thing is efficiency. Training these models takes a lot of computing power. It's expensive. So researchers are trying to make that process faster and cheaper.
Right. We don't want this to be some exclusive tech that only a few companies can use.
Exactly. Another big area is figuring out how to combine LCMs with other types of AI. Like, imagine combining their understanding of concepts with the power of image recognition, AI, or speech recognition.
Wow. So like a more well-rounded AI that can understand the world through different senses, not just text.
Exactly. And as that happens, you can imagine AI helping us solve even more complex problems in medicine, engineering, even art.
It's mind-blowing. But we also need to keep in mind the whole responsible development thing, right?
Absolutely. Making sure these technologies are used ethically for the benefit of everyone. That's super important.
It's not just about pushing the limits of what's possible. It's about thinking about the consequences.
For sure.
You know, as we've been talking about all this, it makes me think back to that analogy of the student in the exam hall. It feels like we're moving towards AI that can truly understand the world,
Yeah.
not just memorize stuff.
It's a pretty profound shift.
And as we keep exploring, I think it's important for everyone to be part of the conversation.
Definitely.
Keep asking questions, don't be afraid to challenge assumptions, and never stop learning.
Couldn't have said it better myself.
The future of AI isn't being decided by some small group of people. It's being shaped by all of us.
And, as we've seen today, it's a future filled with amazing potential, but also a lot of responsibility.
Well said. Thanks for joining us on this deep dive into the world of large concept models. We hope you've learned something new and that you'll keep exploring this fascinating field.
Absolutely. Until next time, stay curious.
So as we wrap up our deep dive into LCMs, I want to highlight something. This research is still pretty new. We're really just starting to scratch the surface of what this tech can do.
Yeah, absolutely.
What are some of the big unanswered questions? Like, what are scientists still trying to figure out?
Well, one big focus is on efficiency. Like I said, training these models, it takes a ton of computing power. So researchers are looking for ways to make that process faster and more sustainable.
That makes sense. We don't want this to be a technology that's only accessible to like huge companies or governments.
Right, exactly. Another area of research is how to combine LCMs with other kinds of AI. Imagine if we could take their understanding of concepts and merge it with image recognition, AI, or speech recognition.
Whoa, that's wild. So we could have an AI that understands the world through multiple senses, not just text.
Exactly. And as that happens, we can imagine AI solving all kinds of problems in medicine, engineering, maybe even art.
That's amazing. But of course, we can't forget about responsible development.
Absolutely.
Yeah.
It's crucial to make sure these technologies are used ethically to benefit humanity.
It's not just about pushing the limits of what's possible. It's about thinking through the consequences and making sure we use this tech for good.
I couldn't agree more.
You know? It's funny, thinking back to that analogy of the student in the exam hall, it feels like we're entering an era where AI can actually understand the world,
Yeah.
not just memorize facts.
It's a huge shift in how we think about AI.
And as we go forward, it's so important for everyone to be part of this conversation.
Definitely.
Keep asking questions, challenge those assumptions, and never stop learning.
Well said.
Because the future of AI, it's not being decided in some lab somewhere. It's being shaped by all of us.
And it's a future that's filled with potential, but also with responsibility.
So, thanks for joining us on this deep dive into large concept models. I hope this has given you a better understanding of this amazing new technology and its potential to change the world.
Thanks for having me.
And to all our listeners out there, keep exploring, keep learning, and until next time, stay curious.